All right, so welcome to the first class in Math 49, and we're going to kick things off with the Chapter 0. And Chapter 0 is not in your textbook. It is in the Duotang if you picked that up from the library, or if you didn't, there is a digital copy in the Moodle site. So you can refer to that for, the one chapter, roughly the 1 week we're going to be working on this stuff, and answer the questions. So the homework questions for this course come out of the textbook, and these notes and these videos are really to help you go through the material and learn the material. So these are the same videos that we're using in class. And if you're in class, this sounds silly to hear me say this, I've skipped my picture in all these videos so that I don't have to see myself in the, the videos that are on YouTube forever. But just do remember that if you're watching these on your own, or if you're watching them in class, that connecting with me and Zooming with me when you could see my face is a really key part of it. So chapter 0 is about arithmetic, where the rest of this course is algebra. And so arithmetic does underlie algebra in that, the principles and the key bits that we use in arithmetic are part of algebra. Certainly there are number components in algebra. It's just that there's no letters in arithmetic. And so we're going to start things off with this factoring bit. And a lot of this stuff is stuff that you've done before, but honestly, probably not for a while. And it's just good grounding review. So the first little bit is about factoring, and factoring is basically the reverse of multiplication. So it says here that factoring is or any whole number could be written as a product of two whole numbers. So product in math implies multiplication. And we're not going to use the x for multiplication very much in this course because there's going to be a lot of other x's when we get into algebra, but that's what we're talking about. So that's true. Even a number like 3 could be the product of 1 and 3, right? So any whole number always has the 1 as a potential factor to it. Now, a lot of other numbers have more factors. So any factor of a whole number is that whole number divided out, and the other number is the other factor. So that's really wordy. And just as a reminder, in your purple formula pages is a multiplication table. So you might be a little rusty on some of your multiplication facts. And so no harm in that. You have that multiplication table, and you also have your calculator, which you are welcome to use for absolutely everything in this course. I would highly recommend getting that calculator sooner rather than later so that you can practice using it and get familiar with it. So in the textbook, it says, okay, well, listing all the factors. And so the textbook uses the rainbow method, and it's quite, well, kind of cute sounding. I don't know that it's the best method, but that's what they do. So they say, okay, well, let's list all of the factors. And ideally, if we could list them in order from smallest to biggest, that's the way the textbook does it. So it does this thing where, okay, 1 would divide into 12, and 12 would be that other part there, right? Those are the two factors that multiply to give you 12. 2 would also divide into 12, and 6 would be its partner, right? Because those two would multiply up to 12. 3 and 4. And in this way, you've made this list of all the factors of 12. So if we do 18 in this rainbow method, 1 and 18, 2 and 9, and 3 and 6. Easy peasy, right? Now, the thing with them is sometimes you don't know how much space to leave, and so sometimes you can end up with this big gapping space, or you end up with like a lot of factors all squished in here. And if you're getting bored, fast forward and try 72 over here with this rainbow method. So before I do too many more, I'm just going to play with these first two with another method, and this is a method that is more maybe me. But it is something that we're going to use later on. So the way I write it, when I want to list all the factors, I put the number at the top, and then I'm going to put those pairs down below. So it's exactly the same thing, literally. Really no difference in your answer. And honestly, it doesn't matter how you get to the right answer, so long as you can get there. So I put the pairs down like this. And for me, that's a little bit easier. The other thing is when I kind of go through, starting with smaller and getting bigger, when these two get really close together, I know that I'm done. So that's the upside down rainbow or smiley face, I guess. I don't know. Never thought of it that way. But so 18, if I do it that way, I'd have 1 and 18 because 1 and the whole number are always factors of any number. 2 also divides into 18, and so that would give me a 9, and I could do that on my calculator. 3 would work with a 6. So we can try a lot of these ones. I'm going to stop there. In class, we're going to go on from that point. But maybe, the ones over here like this F is a bit of a challenge. So if you're working through this video on your own, I would refer you to the key that you will find that has all of my work shown for these other ones. So these videos will be kind of the basics. And in class, we'll do a lot more examples. And if you're working on these on your own, then it's up to you more to kind of track down those keys to kind of test your knowledge. If there's any that are ever particularly tricky, I will kind of give you the heads up on, or maybe I skip ahead and do some of those ones just so that you don't get caught with some of the oddballs. All right, so we're going to move on past that. You can pause here or keep chugging along. So the next bit on the notes is about how we classify numbers. And we can classify numbers as either prime or composite. So basically, prime numbers only have one end themselves as factors. They don't have any other factors. Prime numbers would not be on that multiplication chart. All the other numbers, if they're not prime, then they're composite, except for, as I get down to here, the oddballs, which there's always oddballs. So prime numbers not on the form or in the multiplication chart. Composite numbers are. Composite are examples. All of those ones up above here are composite numbers because they have more than just the number in it and 1 as factors. So if we circled the prime numbers here, 17 is prime because there's no other factors. 29 is prime. If you're not sure, try a few things. 33 is a weird number, but it is not prime. I could factor that with 133 and 3 and 11. Those are all factors. And so because it has more than just itself and 1, it is not a prime number. Down here, circling the prime numbers, 2, technically prime. It's definitely even. Don't get confused between even and odd. Those are different classification of numbers. 6 would have more than just more factors. 9 has lots of factors. 11 doesn't have any factors other than 1 in itself. 15, lots of factors at 3 and 5 makes it a composite number. 19 is again prime. 23 is prime. And 41 is prime. So doing the other way, circling the composite numbers, we're looking for the reverse of these. And so we're looking now for the numbers that you could factor, like we did above. So I'll do 1 here. So we've got 18, also composite. 25 is composite. And 28, that says there, is composite. Down below, the composite numbers, 2 would not be a composite number. 6 would. 10 would, and I've stopped talking, but still circling. These are all the composite numbers. So hopefully I don't make a mistake as I go through these videos, but we are all prone to making simple mistakes. So sorry if any of that's misleading. And again, if you have any questions about anything, please ask. So I put a little arrow down here. 0 and 1 don't classify as prime or composite. This is the first time that we see the 0 and 1. And honestly, if we could remove all zeros, ones, and negatives from our confusions or mistakes in math, and we'd all be a whole lot better. So the next little bit here is on factoring a composite number. And so it basically says, like what we did before, we had just listed all the factors, but there's different ways to factor a composite number. So this should be on the next page. So if we wanted to factor numbers, we could write them out as the prime factors. So if we wanted to break something down to all the prime factors, we break all of the factors down until we're left with only prime numbers. So it sounds really confusing in words oftentimes with math, which is where the videos come in. And sometimes it's better for me to show you, not tell you. So factor trees are a common way with the prime numbers. So I'm going to do this 72, which you may have done on the first page. It has a lot of factors. And I'm going to start small. I like going simple and small. And I'm pretty good at dividing by 2. So I could break 72 out into 2 and 36. And 2 is prime. So that's good. I'm done with that. But 36 is still a composite number. So I need to break everything down until we're left with only prime numbers. So I could break that out into 2 and 18. And then I could break 18 out, I like dividing by 2, into 2 and 9. And then I could break 9 out into 3 and 3. And so this is a factoring tree. It might be the way that you've done this in the past. So if you ever have done this kind of stuff, I'm not here to reinvent what you know, but that's one way to take a look at it. I'm going to do this another way. Actually, before I do, I could circle all these. So if I wanted to list the prime factors here, it's basically, and I think this is why it's called a tree. I'm going to get fancy. If this was a leaf, and this was a leaf. This is a very lopsided tree. That's why they call it a tree. Okay, so this is done as a chart alternative down below. It's really the exact same information, but it just looks a little different. So I'm going to do this another way. So there's so many ways. Whoops, am I erasing? Okay, hang on. Oh, there we go. There's so many ways to do this. So maybe you didn't want to divide by 2. Maybe you're like, oh, I know my 9 times tables. And you know what popped into your head, or what maybe did pop into your head, is that 72 could be, whoops, sorry about that. Hang on. 72 could be divided by 8 and 9. So breaking that down into those numbers, you have to keep going until the factors are prime numbers. So 8 could be broken down into 2 and 4, but I'm still not done with that 4. That could be a 2 and a 2, and the 9 could be broken down into the 3 and the 3. So if I did this and switched, pretend I did, oh, I will. I like the colors. I'm sure the videos will get better as I learn more and more about this stuff. So those are the same numbers as I ended up with before, right? We've got a 2 and a 2 and a 2 and a 3 and a 3. So same thing. Doesn't matter the order that they get listed in. This list, what I drew the leaves around in whatever tree version you wanted, or this chart lists the prime numbers. So in my experience, people seem to gravitate towards the tree, but any times that I can show you that there's multiple ways of getting somewhere, I'll try and do that. But you do not need to do things multiple ways. If you have one way that works, that should be adequate. So I'm going to do one more in a tree and then go back to that idea of dividing by little numbers. So I could break 60 out into 2 and 30. I could break 30 out into 2 and 15. And I could break 15 down into 3 and 5. So I'm going to pause the video here, give these two a try. I know D is a wacky huge number, so definitely check your key on that one. And I'll just suggest to start with small numbers. And see how things go. One little note on the chart, if you are trying the chart, and in the key you'll notice I did all of these with the chart as well, just to support whichever way you choose to do this. Once you get down to breaking that 4 out, the 2 and the 2 both go in this column because they are prime factors. And so a little bit of a weird way, I mean, you can ultimately, like I said, get to the answer in several ways. And so give C and D a try. We'll do those in class together, or give you some time to work on those. But if you're not in class and just watching this video, pause the video and give these two a try. All right, hopefully this is working for you. If you've ever worked in industries that tend to shorten things into acronyms, and honestly, we all have, I'm going to introduce you to two TLAs. So my husband works in the ski industry, and he talks about all the acronyms that he has to deal with. A TLA is a 3-letter acronym. So just a bit of a joke on that, because there's so many acronyms. I don't think we need to abbreviate everything into letters. So we're going to talk about the GCF, which is the greatest common factor. And we're going to talk about the oh my goodness, my brain just fell apart here. LCM. So GCF is the first part of this last section in 0.1, and LCM LCM. So greatest common factor and lowest common multiple. I get the letters mixed up and I'm way happier saying the words with these. But this is what we're dealing with are these two 3-letter acronyms. And they're another way that we can use this idea of factoring to find answers in math, I guess is the best way to do this. So we're going to take a look at the greatest common factor of 20 and 30. So like I said, it's easier to show you than to tell you. So the word of this is the greatest common factor is the biggest number that would divide evenly into both of these numbers. So saying it that way, you're likely going to know the answer to this. And there's nothing wrong with knowing the answer and having that intuitive response to math. But the problem comes the problem comes when things get trickier and you don't know the answer. And so what this course is designed to do is to give you a system, a way of understanding or looking at the material so you can figure out what that answer is. So bear with me on this one. If you're like, wow, that is a really complicated way to figure out something I already know, I often choose these examples that you know the answer to use for our first few examples, because hopefully that allows you to buy into the process and understand things a little better. So we're looking for the greatest common factor, and this is a little bit like the chart system that we did up above, or maybe you didn't do up above. And so this column here, it doesn't have prime factors like the last chart did. It has the greatest common factor. So I'm looking for the greatest common factor, or any factor, honestly, that is common to these two. So I could divide both of these by 2. I told you before I like starting small. So if I divide 20 by 2, I get a 10. And if I divide 30 by 2, I get a 15. It's just a way of working through this material to generate your answer. So now I take a look at the next row. I'm done with these numbers on top. I've now reduced them to this. So 10 and 15 share a factor of 5. And so if I divide 10 out by 5, I get a 2, and divide 15 out by 5, I get a 3. I know this seems really complicated for something you already knew the answer to. So please bear with me, just listen along. And I promise we'll get to one that this is actually useful in. So now to get to the answer, the greatest common factor is 2 times 5. And you're like, awesome, Marianne, this is what I already knew. So thanks for confusing me. Um, The greatest common factor of 20 and 30 is 10. The biggest number that divides evenly into both of those is 10. So let's try another one. And again, you might know this one intuitively, so bear with me. So I'm looking at 30 and 36. And again, just to see the pattern on another one that you know the answer to. If anybody's not sure, I think we're going towards 6 as the greatest common factor with these two. But again, that's what I know intuitively. So working slowly, start small. Both would divide by 2. That'll leave me with 15 and 18. Both of these divide by 3. So that will leave me a 5 and a 6. And I know I'm done here because there's nothing that these two share as a common factor other than 1, but that would just keep my list going forever. So once I'm down and these numbers at the end of my columns, I can't find a number that they share as a factor, that's when I'm done. So my greatest common factor is going to be the product, remember that's multiplication, of these two numbers. So there's the 6. So moving on to the next page with this, you can do this for more than one number. So I'm going to do the next 2 examples here. And then I'm going to give you a heads up on H. So the next 2 examples, I'm looking for the greatest common factor of 3 different numbers this time. So I've got 24, 30, and 36. And again, you might know this number intuitively, but we might be moving into the territory that's harder for you to consider all 3 numbers at the same time. So my strategy on this, the way to get to the answer if you're not too sure what it is, you're going to take a 2 out of all of these because they're all even numbers. So I'm left with a 12 and a 15 and an 18. And then I can take a look at these 3 numbers, and they share a common factor of 3. They're all divisible by 3. So I've got 4, 5, and 6. And I'm done here because these they all don't share that common factor. Remember, that's what the C stood for, was common. And in this chart system, I have to have a common factor in these numbers in order to keep going. And so for this one, the answer is whatever these numbers are multiplied together. So 6 would be my answer. That is the greatest common factor. That's the biggest number that would divide into these three numbers evenly. Okay, so if you've been listening along and using some patience, saying, wow, really confusing for something I know how to do, this is the question I've put in here as an example to, make you double think that one. So if I look at these three numbers, I don't think there's many amongst us. I know I can't do this. The greatest common factor, the biggest number that would divide into all of those evenly, is harder to know intuitively. So I'm going to go through this with this same strategy to try and find that biggest number that divides into all of these evenly. So I'm going to start as small as I can, and I have been starting with 2 a lot, but the problem here is that these are not even numbers, and they're not going to divide by 2, but all the numbers will divide by 5. And so if I divide all these numbers by 5, and in all honesty, I'm cheating looking at the key over my shoulder, I'd get 21, 28, and 35. It might be worth using your calculator for those ones. Now that I take a look at these three numbers, I'm looking again for a number that they all share as a factor. And so they are all factors, or so they all have the factor of 7. So dividing that out, I'd be left with a 3, a 4, and a 5. And I know I'm done because these three numbers, they don't share a factor other than 1. And so this is where I'm done. So the answer here, and again, probably not known intuitively, the greatest common factor of those three numbers is 35. Your textbook, if you don't like my chart system, your textbook gives you an alternate system for doing these. And over the years, I've gravitated to this system. There is nothing wrong with the way your textbook does it. So if you're like, wow, I've never seen that before, I think I had another way of doing it, then I would encourage you to take a look at that chapter 0 from your textbook and see if that suits you a little bit better. So I'm going to leave the video here. Again, if you're watching this on your own, pause the video. In class, we're going to pause it, and we'll take a look at the next three. For H, just a heads up, double check the key. That is a bit of an oddball. So I'll give you the heads up on that and remind you to kind of take a look at that one on the key. In class, we'll go through it, but sometimes H is a reality. And so just remember that. So give those ones a try. And then we have one more topic, the last 3-letter acronym. So that's the end of greatest common factor. So the last topic here is multiples. And so this is going to build up towards the lowest common multiple, the LCM, that second 3-letter acronym that rounds out this first part of chapter 0. So multiples are like skip counting. We all did it in grade school. And so if you skip count, you can find common multiples between two numbers. And so you can kind of do it intuitively. 4 common multiples of these two. So 15, if you multiply the 2 together, and then if you just keep doubling that number, 30 would also be, 45 would also be, and you could use your chart or something like that. Now, you can find common multiples, and they just get huge, but what's usually of interest to us is the lowest common multiple. So that's where we're going to go next, is the lowest common multiple. And this is something that is used in the next section of chapter 0, sometimes known as the F word in math, but fractions. And so lowest common multiple is the smallest multiple that of any group of numbers. So again, there's a handy system. And again, I would encourage you to not use maybe the acronym here because we forget what that means. So instead of GCF and LCM, fine if you get it, but remind yourself what those words mean. So lowest common multiple. It's the smallest number that both of these numbers would divide into. So factor, greatest common factor is going small, smaller than your numbers. Lowest common multiple is going to go bigger than those two numbers, but not too big. So lowest common multiple, so 6 and 8. And we're going to do this similar to the way that we've been doing these ones. So we build on a strategy. Now there's a key difference between the GCF and the LCM, and I promise to point that out as we move forward here. So in this chart system, this first example is a little disappointing because there's something that happens that I really like. So starting small, 2 would divide into both of these, and that would leave me with a 3 and a 4. Now in this one, it's not like they line up here. So we're going to take the lowest common multiple. The way we get to the answer here is to multiply all these 3 together. So we'd end up with 24 as the lowest common multiple. And this might be something that you could have done intuitively, thinking about what's the smallest number that both of these two would divide into. So let's keep going because something I think a little more interesting is going to happen here. Oh, but not on this one. So LCM of 10 and 18, starting small again, go with the 2. My handwriting's getting neat or messier, sorry. And we'd have a 5 and we'd have a 6. And these two don't share anything. So again, we'd multiply these two together and we'd end up with 90. Oh, did I do something wrong? No, 10, not 90. Oh, that's a 9. There we go. It's like there's something wrong. That is not 90. Okay, there's my mistake. Sorry. Okay, so this one is where things are actually going to work that I think, or look how I like them to look. So we're looking for the lowest common multiple of 20 and 30. And so we break this down. We go 20, that's a 10 and a 15. No mistakes, hopefully that time. And then these two share, again, a common multiple, or a common factor, sorry. So we'd have a 2, or sorry, it's a 5, a 2, and a 3. And look at this. If we take not the straight line this time, but you see how this makes like a big L shape, right? The L that's right there. That's the kind of thing that I really like when pictures and math and everything all come together. I get a kick out of it. You don't have to. So 2 times 5 would be 10. 20 times 3 gives me 60. And again, you might know this one intuitively, but this system gives you a chance to have a way when you're not sure on how these go. So I'm going to do one more. I'm going to do G down here in the video, and I'd encourage you to take a look at these other ones using the key that's posted on Moodle so you can kind of fill in the blanks. And whoops, sorry. We're going to, I just lost that. We're going to take a look at this one because this one illustrates how these two systems, the greatest common factor and the lowest common multiple, are similar but a little different. So 12, 18, and 20. And I'm looking for the LCM. And I'm hoping that it makes that cool L pattern because I think that's really neat. So these three numbers start small. They all share a factor of 2. So I'd go 6, and I'd go 9, and I'd go 10. Now, this is where things are a little different. In the lowest common multiple, you can actually pick and choose. So greatest common factor, they all had to share a number for you to write it out here. In this one, you can pick and choose. So this gets a big asterisk because these systems are similar but slightly different. So lowest common multiple, the L-shaped thing, you can keep going. So I could take a look at the 6 and the 9 and say, okay, those two share a 3. So that would give me a 2 and a 3. I'm going to ignore this 10. He wasn't part of the game. He wasn't part of the party. So I'm just going to bring him down and now take a look at these 3 numbers. So with these 3 numbers, I've got a 2 and a 10 that I could consider as having that shared factor of 2. So that would give me a 1. This one, again, wasn't part of the party, so I'm going to continue it down, and that would give me a 5. So now that I've considered all of the common factors, now I'm done on these. So this one is different because you can pick and choose. The GCF, they all have to be the same. The LCM, you can pick and choose, and that's really the key difference. That's why I put the star here in the notes. Okay, so now taking all of these, that is definitely a big L, and multiplying them all together, that's how you get your answer. So 2 times 3 times 2, blah, blah, blah. We end up with 180. And again, we're in the realm probably where we've we set aside that intuition, the knowing the answer, because math is great if you know the answer. But that's not how you teach math, and that's not how you learn math. That's where you get to. And so oftentimes I'll really stress in this course the system that you can follow to get to the answer. So highlighting these ones is kind of the basics. Do give the other ones a try, and that is the end of 0.1.